Hello, today I am going to present a video on digital twin for unmanned aerial vehicles. My name is Yusuf and I'm going to present this video. Okay, here you see the list of outline. We start with unmanned aerial vehicles, continue with digital twin, talk about simulation to reality challenge, safety, integration of digital twin with AI, and finally present the reference. Okay, unmanned aerial vehicles, commonly known as drones, have made considerable progress in recent decades. They have found different applications in different sectors. For example, UAV are widely used in energy sector, in agriculture, in public safety. Okay, UAV have some advantage. The first advantage of UAV is establishing a line of sight communication with user. Another advantage is ability to optimize mobility, and also they are cost effective and they can quickly to be deployed. Okay, UAV can take different role. For example, they can take role as aerial base station, take role as aerial relay, or take role as aerial data collector. Okay, digital twin. Digital twin was proposed by Grieve in 2003 and was one of one of Gardner 10 most promising technology trend for 2018. Okay, digital twin enjoys great popularity as a multi-physics, multi-scale, and ultra-fidelity simulation that reproduce the state of a corresponding twin in real time, based on historical data, real-time sensor data, and physical models. Okay, what does mean this multi-physics? They can simulate multiple physical phenomenon simultaneously. They are multi-scale. They can model different level of a system, and they are ultra fidelity simulator. Um, their data that they use highly resemble the real data. Okay, and as I said, they can reproduce the state of a corresponding twin in real time based on historical data, real-time sensor data, and physical models. Okay, digital twin technology is integrated with UAV to improve UAV design, traffic optimization, quality of service, and safety. Okay, digital twin replicate UAV elements, process, dynamic, and firmware in a digital counterpart. Okay, the physical and digital counterpart can share all input and operation through real-time data communication. This is key fact about digital twin. Physical and digital counterpart can share data using real-time data communication. Okay, a UAV swarm with different aerial roles can be modeled using digital twin to enable collaboration, promote safety, and address problems such as the simulation to reality gap. Okay, simulation to reality. In UAV, the complexity of real-world scenario make it difficult to create a simulation environment with a high degree of accuracy. Okay, we have a real-world scenario, a complex real-world scenario, and it is difficult to create a simulation environment with a high degree of accuracy. Okay, moreover, the model learned by AI algorithms from simulated environment are difficult to deploy in practice without extensive processing. Okay, when we train AI model using simulator, it is not easy task to deploy the trained model in practice. We need a lot of processing to deploy the simulated model in practice. Okay. In summary, the gap between simulation and reality limits the application of AI to UAV. Okay. One of the main limitation of the UAV is that the gap between simulation and reality. When we train an AI model using simulator, we cannot easily deploy it in practice and use it in a real world. There is a gap between simulation and the reality. But digital twin can address this gap. Okay. uh, Once a digital twin is synchronized with its corresponding real twin, it contains accurate system state information. Okay, let me tell you in simple language. When we create a digital twin of a real twin, we have high fidelity data that closely resemble that real data, and we can train the AI model using this data in digital twin. In this way, we can address the simulation to reality problem and alleviate the effect of it. Okay, so instead of training AI model in simulator, we train AI model using digital twin with high fidelity data, and then quickly deploy this model in practice. Okay. As you can see here, the AI model can learn from DT and be quickly put into practice with the help of digital twin. Okay, this is the point. Safety, improving safety is a primary concern in UAV. By using digital twin technology, which create a virtual replica of UAV, we can gain better control over UAV and its operation. Okay, the point is that when we use digital twin technology, we create a virtual replica of UAV. In this way, we can better control UAV and operation, and we can better manage the complex scenario of the UAV because we have a digital twin of the UAV and its operation. We can better manage its navigation, and therefore, significantly, we can improve the safety. Okay, so once again, we create a virtual replica of the UAV, and using that we can better control UAV and its operation and manage its complexity and complex scenario. In this way, we can improve the safety. Okay, integrating with AI. AI can provide advanced analytics and decision making capability. I think all of you are agree, enabling UAV to self optimize, self configure, and self heal. Okay, digital twin and artificial intelligence are expected to play crucial roles in developing and deploying UAV. Okay, integrating digital twin and artificial intelligence provide a powerful approach to the modeling, simulation, and optimization of UAV. In scenarios such as UAV navigation and trajectory planning, digital twin can be used with ML model and build a predictive model. Okay, we can integrate DT and AI, create a powerful tool for modeling, simulation, and optimization of UAV. And for example, in scenario of trajectory optimization, digital twin can be used with machine learning model to build predictive models. Okay, this is the reference. My paper published in archive. It's a worth reading paper. I recommend you to have a look this paper and carefully read it to find more detail about the video subject. Okay, thank you very much. If you learned something from this video, I appreciate to like and subscribe.